Hello everyone. In this session, we learn about the queue data structure and its implementation in the Python by the concepts of object-oriented programming. First of all, we discuss the data structure queue. A queue is a linear type data structure that is used to store the data in a sequential manner. The concept of queue is based on the first in, first out. That is, who come first serve first. The queue has two open ends. One is called front and another one is called rear. For the insertion from the rear and remove from the front end. As you saw in the given figure, empty queue have front and rear at -1 position. When we insert our first element, that is called end queue operation. Then second operation, repeat the same task and add the other end. When we perform DQ operation, then remove element from the other end, that is called front. These are the basic operations that perform on a queue data structure. And queue, in the abbreviation, it add or insert the new data to the queue. The backside is referred to as the rear and return the first element from the end of the queue. DQ remove and return the data from the queue's front. The front is named to given to the side front. Return the first element from the start of the queue. Is empty, check if the queue is empty, or is full, check the queue is full. In the given figure, you saw the NQ and DQ operation. Before going to programming phase, let's be consider backing of queue. Queue operation back as follow: two pointer front and rear. Front track the first element of the queue and rear track the last element of the queue. Initially, the set value of front and rear to -1, as you saw in our figure. Front and rear in an empty queue set at -1 position. Now, AND queue operation. Before inserting a new element to our queue, first we check queue is full or not. If the queue is full, then no operation is performed. Otherwise, for the first element, set the value of the front to 0 and increase the rear index by 1. Add the new element in the position pointed by the rear. In the DQ operation, check if the queue is empty, then there is no DQ operation performed. Otherwise, return the value pointed by the front and increase the front index by 1. For the last element, reset the value of front and rear to -1, as you saw in our given figure. Now, perform the implementation by the concept of OOPS. We create a class queue, define constructor, then define the function is empty, is full, NQ and DQ. To check full, if rear is equal to max size -1, and max size is the capacity and maximum number of elements that have a queue. If the condition is true, then return true, either false. For the NQ operation, pass the one argument that is called data. First, we check queue is full or not. If queue is full, then return. Otherwise, if front is equal to -1, that there is no element in our queue, then set rear and front equal to 0. Perform the NQ operation. Otherwise, rear equal to rear plus 1 and insert the new element. To delete when we want to delete an item from the front, then we first check either our queue have any item or not. So check is self is empty, print empty queue if the value is true. Otherwise, rear equal to self dot front, then there is only one item in our queue, set equal to none, and update the value of rear and front at -1. Otherwise, update the value of front plus by 1. To implement our concept, we use the ideally given by the Python. We run our code. Code runs successfully. Now create your object of class Q, set the size 3. Q implemented successfully. Now perform the NQ operation to insert data elements. We insert A, inserted A. Now perform the same operation. Repeat this task again. Insert B, inserted B. Repeat same task again. Insert C, C is inserted. Now insert D, full Q. We take the maximum size 3, so there is only 3 elements are inserted successfully, and whenever we want to insert the next element, that is called D, fourth element, then full Q. Now we perform the DQ operation or remove elements. There is no need to pass any argument. The element at the front, the value of front is at 0 and the return value is A. Now perform the same operation again. Now update the front value by 1 and value that is returned or DQ is B. Perform the same DQ operation again. Front at 2 and value equal to C. So these 3 values now removed from the Q. Whenever we want to perform again, repeat the DQ operation again 4th time, then we get empty Q. There is no element which will be removed from this Q. So you successfully implement the Q data structure in Python by the concepts of OOPS. These are the references which I used